Hello everyone, this is Professor Keene. We have begun our study of Benjamin Franklin's experiments and observations in electricity. Last lecture we talked about his description of how a sharp object is able to draw off the electrical fire, as Benjamin Franklin put it, from electrified objects. He imagined taking an iron shot and placing it on top of a glass bottle, a dry glass bottle, rubbing a glass rod with a piece of leather or silk, touching it to the iron ball, and watching it exert a repulsive force on a cork sphere hung from a small silk line next to it. But if you were to place a sharp iron bodkin or other sharp object near the iron shot, it would draw off the electricity. That is, the formerly repelled cork sphere near it would then fall back toward the iron shot. If you want to review that, you might want to look back at the old lecture. What I want to talk about this time is I'll continue in his letter number 2, which is shown over here. Letter number 2. This is on page 35 of A Student's Guide to the Great Physics Texts. And we'll continue to talk about his description of the drawing off and throwing off of electrical fire. Okay, so like I said, we've been talking about how a sharp object can draw off or reduce the electrification of an object. Now let's talk about throwing off of electrical fire, as he puts it. So he mentions down here at the bottom that if you were to take this sphere, this iron sphere, that is placed on top of a glass bottle. You might imagine the glass bottle like this. The glass bottle is placed on a table. And you were to take a silk fiber and a cork ball, and if you were to electrify this iron shot, what would happen is that this cork would swing up like this, and let me draw it in a new position. It would be repelled from this when it's electrified. So electrified, go like this. When it's electrified, it will swing away. But he mentions in this section that if you were to take a needle and place it on here, what would happen is that this cork ball would fall back toward it. In other words, the point is that the needle placed atop the iron shot, he would say, throws off the electrical fire. And again, you might want to remember, if you're upset with how he's referring to this as electrical fire, you might just think about, we don't see electricity. But what you do see is if you put this in a dark room and you have this needle on top of it, there's a slight glow on top of the needle. So this is where Franklin gets this idea that it's sort of throwing off this electrical fire that's somehow contained within the iron shot after it has been electrified. He also mentions another experiment where if you take a gun barrel and you electrify it, so imagine a gun barrel right here, you can electrify it. It behaves kind of like this iron shot. This is our gun barrel. It will become electrified unless, of course, you hang from it a bayonet. So a sharp object like this, the bayonet, and when you do so, it cannot hold its electrification because there's sort of this electrical fire that is thrown off of this, kind of like the electrical fire is thrown off of the needle in that case. Okay, so he also mentions, and maybe we can jump to the next page. Right here, he mentions up here some other ways that one can reduce the electrification of an object. First of all, by sifting fine sand onto it. So if you were to take this iron ball atop the glass bottle and electrify it, and you were to sift fine sand into it, it would lose its electrification. Again, we know that because the cork ball falls back toward it. If you breathe on it because your breath is humid, that also reduces the electrification. Or if you light a fire near it and have smoke passing past it, then it will also lose its electrification. One of the things that's interesting is down here, he mentions that if you take a looking glass, you might imagine a magnifying glass, and aim sunlight at it, it is not able to reduce the electrification of the iron rod. I only point this out because Franklin is achieving a negative result here, but later on Heinrich Hertz in the late 1800s in his studies of electromagnetic radiation, he mentions that when you shine a bright light on a charged ball, it does discharge it. And then later on, I believe it's Angstrom, I'll have to double check that, but he studies how light can knock off electrification from metal surfaces. This comes to be known as the photoelectric effect. Photo because light, electric because electricity, photoelectric effect, light throws electricity off of an object or de-electrifies it. This, interestingly, becomes one of the central features of quantum theory. Einstein incorporates this into his 1905 theory of the photon. So that's just a heads up here. The kinds of things that Franklin is thinking about will eventually lead to quantum theory.